So a pointer points to a location in memory, and here we have a pointer which points to 100 bytes of memory, and we point to that malloc. And now we are pointing to the first element of that malloc, the first char element, and then we are copying hello world into it. So we have a char array. Because a pointer is only pointing to an element, we can iterate over the pointer. So if we first print p, it's gonna be hello world, right? But we can iterate over p. So if we want to move 5 elements, we can do p plus 5. We can add it. We can add and subtract pointer, and it will move per element, right? So we have plus 5. It's gonna move 5 elements, right? And then you can also, if you want to append a string to the end of hello world. For example, we want to add a string. You can use strcat, right? But say if you already know where the string ends, you can do a string copy with p plus put the length of the string if you have it. But yeah, but if we do this, and print it, it's gonna be, wait, why is it, oh, -1, yeah, size of -1, or let's just do strlen because it's gonna get optimized to a size of anyway. But yeah, so that works. How does that work? Well, we have p, which is pointing to the h, right? And then we just add the another string. The another string is going to start at the end of hello world, and you can also do all sorts of things. So if you want to remove hello world and then remove the h and then move the string, like do a pop front, you can do mem move and p, and then I okay, I'll just strlen p, right? Okay, p, we can move what what do we want here? Well, we want to remove the h, but we don't want to iterate over the string because we still want to free it, and want to actually remove the h. So we will just move the p plus 1, which is hello world without the h, right? And then we'll move that to the original position, which is hello world, but now it will move the hello world to hello world, and then it should remove the h, right? So just do puts wait wait a minute, p plus 1, oh, that's the destination. Okay, oh, so okay, that's backwards, but it's hello world. Now we also, well, we need to move we need to remove the D because, well, it is just a mem copy, right? It copies hello world and then it copies that into P, right? But we need to do the cleanup. We need to remove the D and put a null terminator instead. And well, if you want to do a push front, then you can, you know, do the reverse, right? So the destination is going to be the second element, right? Because we want to move the hello world to all of them to the second element, and then we will put another character instead of, or in front of, the hello world. So we can do P, because P is the first element, right? So we can just do, you know, something, put a Z there. And yeah, if you want to iterate over this string, you probably want to have another pointer, because if you iterate with the original pointer, or you don't make a save pointer to say the start of the pointer, you can't actually free the pointer, which you want to do. So let's say for whatever reason we want to iterate over the whole pointer and do something, I guess. We can do for, well, I guess not that, but while P is not a null pointer, make a TMP. Now TMP points to the first element. Now we have our iterator, and then we can do something, right? But let's just put let's do a put char here and change that to that. So we are printing each character, but we can still actually free it at the end because we are iterating with a temporary pointer, right? So this is the same as you know, using an int or size t to index it and then like print it. So it's the same thing as this. So TMP, say we have an I, and then TMP I plus plus, or P, I guess, right? It's doing the same thing, but instead of index, the pointer points to the elements directly. If you want to dereference a pointer and then like dereference the second pointer or something, or an nth, the nth pointer, like for example here, as you can see, well, you can't really see, but this is actually a wrong way to do it. If what you want to do is you want to dereference the nth element, with 0 being the first element, because what this does is, well, it actually is equivalent to this. So it dereferences the pointer first, because a plus and the dereference operator, has higher precedence. What you are actually doing here is you're dereferencing the P, so in this case the first element, and then you are adding n to it, which, you know, doesn't make sense if you want to. This is what this isn't what we are trying to do. If we try to print p, or I think it's did I do puts here? Okay. It's just a memory location, right? So it's just a hex number, and you know, if we iterate over p, so p plus 1, it's just going to be you know, it's the previous number plus 1, because, well, character is 1 byte, right? So the next character is going to be in the next byte, because, well, that's how it's stored. Well, it's if it's an integer. So for example, we have int p, and print f p. So p1 is our p1 and p2, right? So what about integers? Well, an integer in this case is 4 bytes. Well, it depends on your machine, I guess, but if we do p plus 1, it's going to go to the next 4 bytes, because we have that information. The compiler knows that it is a pointer to int, which in this case is 4 bytes. So p plus 1 is going to go to the next element, which is the next 4 bytes. It's going to skip over the first element, right, which is an int, a 4-byte int, and go to the next element. So yeah, hope that helps. Yeah.